and the kind of images that our astronaut was showing us, and we realized we don't really know as much about this planet as we thought. And every day new and new material is coming forth, particularly from the satellites orbiting the planet. It's just quite remarkable, the wealth of information that is so productive in terms of our learning about what's going on in this planet. I have always been fascinated with geology. Ever since I was a young lad living in Vancouver, British Columbia, where there was very little bedrock where I lived, but I kept my hopes up that I might find a fossil. So those hopes were quite shattered. But as soon as I had the opportunity, I went to places where there were live volcanoes. And my first one was to Guatemala, and we climbed to the top of this volcano at night, and the idea was that we would be there as the sun rose, and we would get this incredible vista with the sun rising, and there were other volcanoes nearby, and it worked out perfectly. And in the morning, the sun rose, and then suddenly the volcano next to us sent out this cloud of ash. And we realized this is a bit precarious. Luckily, the ash wasn't blown towards us, so we didn't have to breathe that stuff in. But, you know, I really started to come close to this notion that this is a dynamic planet. Well, I took Jan on our honeymoon to Hawaii, primarily because there are live volcanoes. And I found a cinder cone on Kilauea, and I thought, this is perfect. So Jan, newly wed, came with me to the top of the cinder cone. And we're standing at the top, and we smell someone's burning rubber. Tires. I think, this is ridiculous. And then our feet get really hot. And literally our Vibram soles were melting. And so we got out of there. It was a live cinder cone. Jan wasn't impressed, but you know, I think I should still write Vibram about that. Well, we shouldn't have gone past the sign that said area closed. But you know, I've been hearing rumors on the ship, people commiserating with my wife for being married to a biologist. And I want to quell those rumors right now, because Jan is a biologist as well. And all we have to say is, we're going to see some really neat birds, and sure enough, she's game for going on a little jaunt through the Amazon jungle or wherever it might be. So she has a role to play in all this too. We love to go to places like this, Hotwater Beach in New Zealand. This is the kind of plate tectonics that I really can enjoy. If you've heard of this place, or if you've been here, this is where you can customize the temperature of your own little pool, because you have hot, hot water bubbling up through the sand, burning hot, but then the nice cold ocean waves washing in. And you can see the way people have customized the temperature that they like based on the cold and the super hot water. This is one wonderful place. Recently, in 2011, we were off the shores of Guatemala on a cruise ship, and Pacaya, a very active volcano, was in the midst of an eruption. Interestingly enough, it was becoming a big tourist destination. If you look very closely, you'll see some silhouettes on the hill. These are the people who have come to watch Mother Earth in action, close up. And I was fascinated with some of their protective gear. I guess they haven't heard about volcanic bombs, but it would help with ash, definitely, to have an umbrella. But what really impressed me was at the base of the volcano, there was a trail, and many, many people were actually hiking to get closer to where you could actually stand beside a volcanic fissure and see the hot gases emerge, which is not a great idea. But the kids at the bottom were selling two things: marshmallows and forked sticks. And sure enough, people would hike up to the fissure and roast their marshmallows in a live volcanic fissure. Very, very poor knowledge of plate tectonics. Well, so you can see where this is leading. Why I never became a geologist. I chose to go into the other natural history, biology. This is just, you have to really be able to withstand the heat to a much greater degree. So I became a photographer. And I realized that probably was a little bit too close. That wasn't me. I wouldn't do that. Well, you know, you have probably run across plate tectonics. Plate tectonics can be a little bit slow. So I call mine not 101, but plate tectonics 007. Because it is so much more interesting when you treat it as a mystery, which it has been until quite very recently. So today's presentation is really how did we get to realize what's happening in terms of continents moving on this planet, which is an intriguing notion to begin with. But you know, science, many of us through our high school years and those of us who went through university, first of all, we have this impression that science is sort of this linear. You form your hypotheses, you do your experiment, you test your hypotheses, you come up with a result. But you know, it's not so straightforward. It's nonlinear, and egos get involved. You're going to find some interesting people in my presentation today. Well, this is the kind of thing we learn in science. There's more than meets the eye once you start digging deeper. Well, when I was very, very bored on those sunny afternoons, I'd look at my atlas in grade 6 and I think, South America does fit into Africa. I don't care what the teacher says, because the teachers were saying, forget it. So, sure enough, we know now that it did. Thanks so much to this gentleman, Alfred Wegener. He was a meteorologist near the turn of the century. He was well respected. He wrote a textbook on meteorology that became one of the standards of its day. And Alfred Wegener looked at several of the new pieces of evidence for those days that I'll be showing you, and he came up with this notion. He wrote a book called The Origin of the Continents and the Oceans. And in it, he started talking about what he called drift, continental drift. And his book, you can actually look it up online and take a look at it. He was trying to convince people that these continents were floating somehow on the surface of the planet. Well, you know, for those days, when his book came out in 1912, this was not well received. Even though he was a well-respected scientist, they realized he can't explain what would motivate the continents to do that. How would you get continents to actually shift position? But in his book, he was showing things like South America and Africa fitting together. And today we know that if you follow the continental plate margin, it actually does fit together very nicely. Another piece of evidence were several fossils that they found. Quite remarkably, they would find, if you look at this, Australia. There was, follow the green band, Australia, Antarctica, India, Africa, South America. That green band represents one particular fossil species that was found on all those continents. How do you explain that? Except for a very widespread species, but then there were several others that had these fossil records. Matching rock types. When they looked at the geology of the British Isles and compared it to North America, the Adirondacks, exactly the same geologic makeup, chemistry, really the same rocks. And they realized that the only way that that could happen is if those mountains were contiguous at one point. Hard to believe. Europe, North America. Mountains that were the same mountain chain. Well, the hypotheses to explain these pieces of evidence fell largely into three camps. The Fixists. These were the people who said, the planet's like this, it's always been like this, I don't care what you say, it's going to stay like this. Then shrinkers were saying, it's shrinking, you know, if you put an apple out on the windowsill and it gets all crinkly and changes, the Earth is shrinking. And then there were the drifters saying, well, somehow the continents are being propelled around this planet. And none of these people could really get together, and egos became strongly involved to protect their own particular notion. But the drifters, I think, were sort of held in the lowest esteem. And when Wegener came up with his notion of continental drift, they were literally considered crackpots. And the leading scientists of the day were saying things like, this is heresy, high-flying nonsense, utter rot. These were the leading scientists in their opinion. And so Wegener's star sort of declined with the publication of his book. Although today we know things could have been very different. Here's another little interesting piece of evidence. In as far back as 1691, this Robert Boyle, he was a very wealthy gentleman and one of these dabblers in science, and he could show that rocks, when heated to a certain point, would protect or sort of preserve the magnetic field of the planet at that point. This fellow, I call him the Italian hothead, Macedonio Maloney, did an experiment where he heated the rocks from Vesuvius, and he allowed them to cool. The orientation of the magnetic field on that rock had changed, as if it had been recorded by the rock in that heating process. Well, here's some more evidence. I'm going to tell you about a flip that is happening to us on this planet over and over again, and the North and South poles literally will flip, which is kind of a foreign concept to us. We've lived on this planet now for a couple 100,000 years as modern humans. There's been no sign of a flip in that period. It's been almost 800,000 years, over 750,000 years since the last reversal. And the scientists have no really good, clear understanding of how this occurs. It can be if you look on the right-hand side, some of the leading hypotheses indicate that it could be a very messy affair where you get many small poles sort of vying for one another until the poles finally reverse. It can take hundreds, thousands of years for this to occur. And it's largely because of this widely accepted notion of the dynamo theory, that this spinning solid core is spinning inside molten magma of the Earth. And as it does this, it's creating this magnetic field. And this magnetic field leaves behind a record on the ocean floor, in the ocean crust. It's almost as if you could think of this as being an early cassette, magnetic tape. And every time there's a reversal, it changes the pattern as the rocks are being formed in the Earth's crust, in the ocean crust. And I'm going to come back to this point just to show you how this fits in with this whole notion. But it's really interesting to see that we have a record in the ocean crust of this flip happening over 177 times. So we know it's a regular occurrence. It regularly occurs 250, 300,000 years roughly. So you can tell we're kind of overdue for one of these flips. Right now, the Earth's magnetic field has many geologists puzzled, and it's doing some very interesting things. One of the things it has been doing all throughout history is the magnetic pole, which is different from the geographic pole. The magnetic pole is the true north point. It's moving. And if you look at this chart, the bottom red little dots starts in 1900. These are the islands in northern Canada, and you can see as it's traversed from 1900 past the year 2000 to 2005, not only is it traveling far, but it's traveling faster every year. So it's now moving at roughly 50 kilometers a year, which is pretty speedy for something that is integral to our planet. Now here's a map showing Canada, Greenland, Russia, and I have some really bad news for any of the Canadians in the audience, because the magnetic North Pole is leaving Canada, and it's due to be gone by 2050. It's probably headed for Russia. And this is a fascinating book, The Spinning Magnet. I really recommend this for those people in the audience who have no worries or no cares, and you need something new to worry about. Because this might do it. As the Earth's magnetic field changes, we could be in for a shift, or a flip, but of course thousands of years. Potentially,